Chandana Jain, ECE, 6th semester. This is the mini project called Smart Trash Bin. It is easy power supply given to the Arduino board. Inside the this dustbin. So this is the Arduino board, and this is the ultrasonic sensor, and it is the servo motor. The ultrasonic sensor will detect the user proximity about threshold. So I given about 30 centimeter threshold. So when it will detect the user proximity, it will automatically open the lid, and after 5 seconds it will close the lid. So I giving the demo. It is the dust I am throwing to in this. So I am giving the power sector. So about 30 seconds means it will detect, and I thought about 5 seconds it will close automatically.
Hi, I am Adarsh Kumar and my team are Gangotri and Kubra. We are from 6th semester Department of Electronics and Communication Engineering, CBIT Kolar. And now I am going to give a small demo on the mini project, designing of 2:1 multiplexer using cadence tools with 45nm technology we did under the guidance of Professor Samson John, Assistant Professor, Department of ECE, CBIT Kolar. Abstract. This project entails the design of a 2:1 CMOS multiplexer using Cadence Virtuoso, focusing solely on schematic design and simulation. The design process includes creating the schematic, running simulations to verify functionality, and analyzing performance metrics such as power consumption and delay. The objective is to achieve a reliable and efficient multiplexer design. And now, introduction to multiplexers. A multiplexer selects one of the several input signals and forwards the selected input to a single output line. Functionality used to route data from multiple inputs to a single output, and the block diagram of 2:1 multiplexer involves two inputs D0 and D1 and output Y, and select line S, which is used to select inputs. And then objective of the project. The goal is to design and simulate a 2:1 multiplexer using CMOS technology in Cadence Virtuoso. Scope: from schematic design to verify functionality simulation. Objective: power efficiency, to reduce power consumption for battery operated device to make it energy efficient. Speed and propagation delay, to ensure fast signal processing. The design should exhibit minimal delay, which is essential for high speed applications in digital communication. And this is the schematic circuit of 2:1 multiplexer we designed. The conditions for NMOS and PMOS we followed of: length and width is 45 nm and 120 nm respectively for both NMOS and PMOS, with the library GPTK45. GPTK45 indicates the technology library being used. This is typically a 45 nm process node in a generic process design kit. And here is the test circuit for simulation we designed from schematic circuit. It follows 3 V pulses connected to inputs I0, I1 and select line. A VDC is connected to VDD and a ground is connected and output Y is connected. And now coming to the simulation result, here is the result we obtained. In the simulation result, when select line is low, then output Y follows D0, and when select line is high, then output Y follows D1. And now finally coming to the conclusion and future scope. Conclusion: the 2:1 CMOS multiplexer simulation results in Cadence Virtuoso demonstrate correct functionality and provide insights into key performance metrics. By analyzing the transient response, operating points and parametric variations, we can ensure the robustness and efficiency of the design. Further optimizations can be made based on the simulation findings to enhance the multiplexer's performance. Future scope: scaling to larger designs, low power and high performance design, high speed design. And thank you.
Hi everyone, in this session we can learn about design of UART using Cadence tool under the guidance of Mrs. Kavya S, Assistant Professor, Department of ECE, CBIT Kolar. Presenting by Harshit KS, Prashanti and Trisha Jain. This is the program for UART, and this is for receiver logic, and this is the program for the transmitter logic, and this is the test bench program for UART design. After verifying the both programs, here is the output we get, In test bench, what is the inputs are given, it must get in the output side. If we given same output, same input, and it must get out same output at the output side. After running the both RC script and constraint file, we will get the block diagram as is shown in the below. And here is the report about total area required and power. And this is the advancements for the UART design: higher data rates, flow control enhancement, low power modes, higher voltage tolerance, improved signal integrity.
I'm Saran Kartik from ECE Department 6th Sem. This is my friend Aaron Mini from ECE 6th Sem Department. This is our mini project called Multi-Purpose Surveyor Band. It is connected through Wi-Fi. The app will be explained by me and this hardware will be explained by Aaron Mini. First we need to turn on our hotspot, and the hotspot will connect to the Wi-Fi. And if you want to connect to the device, you have to click this. If it is connected now, you can see connected. Then if you function shoot, it will shoot, and if you send retract command, it will start retracting. The rope will be retracted. If you send stop, the rope retraction will stop. And if you want to turn on the buzzer will be turned on. If you want to off, the buzzer off signal will be sent. And a LED laser will be fixed to the board. When the switch is on, the laser will turn on. And switch is off, the laser is turned off. Next, the hardware part will be explained by Aaron.
Now, this USB board is powered by an 1500 mAh battery, which is charged inside. The components used are DC motor, a servo motor, and a switch with a charging cable and a wristband. This ESP32 board is used to convert the programming code into machinery language, and then the servo motor is programmed by an Arduino software. We use embedded C for the programming language, which turns the servo motor to a certain degree to enable the shoot process. Then a PRS sensor is fixed, where movement can be detected using a PRS sensor. Where I want a demo. I request Sharan to demonstrate about the PRS sensor. Now PRS sensor is turned on. If there is any motion near the PRS sensor, the buzzer will on. If there is no motion, the buzzer will turn on automatically.
If any motion is occurred in front of the sensor, the buzzer will turn on. If no motion is there, then the buzzer will turn off automatically. And it is used for detection of animals in the camping while camping, and it can be kept anywhere. It can be recharged by the solar panel kept provided here. And this is an operating switch for operating laser, and this is an on-off switch. If it is on, then it is in charging mode. If it is this side on, then it is on for ESP programming. Thank you.
Design of an elevator control using cadence tool. The source code for an elevator controller as follows. Then save. The test bench code for an elevator controller. Open in terminal. Use the commands shown here. Source. Then multi-step. work library, create CDS library, save, don't include any libraries. Okay. Then in NC launch we have to check the netlist and the test bench programs, the result and the waveform of the elevator control
I am Sushma and my teammate Dikshita from 6M ECE department CBIT Kolar. Now we are going to give a small demo about the mini project we did, that is the traffic light controller using Cadence tool. Introduction. Traffic lights were first invented in the year 1868 at London's House of Commons, where traffic light signals were placed at intersections of George and Bridge Street. Later, the traffic lights were developed in the year 1914 by an American traffic signal company.
Abstract. Traffic light control systems are critical for managing urban traffic flow and ensuring road safety. This abstract presents the design and implementation of traffic light controller using Cadence tool, which facilitate simulation. The controller aims to efficiently manage traffic signals at intersection by dynamically adjusting the light space based on the real-time traffic conditions. Traffic light control system is controlled by a finite state diagram. We have around 6 different states: S0, S1, S2, S3, S4 and S5. In first state S0 we are in north-south state. Once we get 14 seconds of delay, it will be in a green color. Once 14 seconds over, it will go for next state, enable yellow color, that is in S1 state. Once yellow color is detected, it go for S2 state, it will be green color. Otherwise, it will be in a same state only. After 2 seconds, it will go for S3 state, that is in red color. Now we are in east-west state. To get green color again, we have wait for another 14 seconds of time. After that 14 seconds, it will go for green color. After that, it will wait seconds of yellow signal. Otherwise, it will be in the same state only. It will be a yellow color for 2 seconds. After that, S4 shift to S5. The loop will keep on processing.
This is the code we have used in the mini project, and this is based on the finite state diagram.
This is a simulation output we got as a result. Coming to the conclusion part, the design and implementation of traffic light controller using Cadence tool successfully achieved the project objectives. The controller effectively manages traffic light sequence, ensuring smooth and safe traffic flow at the intersection. The project demonstrated the use of digital design principles and EDA tools for real-world application. Future work involve enhancing the controller with adaptive traffic management features using sensors and real-time data.
Hi, I am Puneet and my team are Achyut Kumar and Hemant. We are from 6th semester, Department of Electronics and Communication Engineering, Kolar. Now I am going to give a small demo on the mini project Smart Door Lock System using face authentication. We did it under the guidance of the Dr. G.K. Venkatesh, HOD Department of ECE CBIT, Kolar. Introduction. Face detection is a computer version technology that helps to locate, visualize human faces in digital images. The technique is a specific use case of object detection technology that deals with the detecting instance of schematic object of a certain classes, such as humans, buildings or cars, in digital images and videos. With the advent of technology, face detection has gained a lot of importance, especially in fields like photography, security and marketing. Innovation idea of project. It can detect faces easily with less time of execution. It can detect face in any quality of image, even blur. It can detect single, double or even multiple faces in any image. It can tell the number of people faces in image. It is fully automatic face recognition system. After that, working on principle of smart door lock system. Here we can observe with a neat diagram. The captured image is compared with the image in the database by extracting the eigenface and eigenvalues. With these features, the image is decided to be an authenticated one. Once the image is declared to be an authenticated one, then the door of the system will be opening automatically. Output samples of smart door lock system using face authentication. Firstly, there will be a training model, and after that, initial door will be locked. The presently captured image is compared with the image in the database. Once the image is declared to be an authenticated one, then the door of the system will be opening automatically. That we can observe with neat images here. Conclusion: the face recognition technologies has been associated generally with very costly top secure applications. Summary of benefits and technical requirements, feature developments and potential applications. Government and NGOs should concentrate and promote applications of facial recognition system in India in various fields by giving economical support and appreciation. And thank you.